Hello, this is Jahirul Amin, and this is going to be the first tutorial in the series that runs through how to rig up this character that we modeled towards the end of last year. This is an introductory series, so we're going to look at the very basic tools and techniques, and then hopefully start to build on them to get a fully animatable character. Before I begin, I'll just give a quick breakdown of what's going to be covered today. So we're going to look at parenting and hierarchies, constraints, joints, rotation order and gimbal lock, and then creating animation controls. The reason we're covering these, they may seem very basic, but I think it's important to have a good understanding of how to utilize them when creating your character rigs. So, in the meantime, I'm just going to open up a rig that I've recently finished, and hopefully to give you a quick breakdown of just what goes into a rig really, and then what a rig is for those of you who are not really sure. So this is Charlie, I guess I've named him, and what you're seeing on the outside, these rings all around him, are the control rig for this character. So if I grab this control, this will move him up and down, and if I grab this one here, that's going to move his hips around, and so on. So this is the control rig for the geometry. So these are the strings you could think of for the puppet, and this is what the animator is going to grab. Oops, I've got some layers here for the geometry, so we can just hide that. So so again, very simply, a rig is going to deform the character. It's the one of the simplest ways, or one of the most effective ways to deform a piece of geometry. If I open up this layer, we can see here is the skeleton that's driving the geometry, and then on top of that we have the rig that drives the joints. Okay, and that's the aim of this series of tutorials is going to be to first build the skeleton, break it into separate parts. So we'll work on the spine, then we'll work on the neck and head, then we'll work on the arms down to the hands, legs, and then feet. For each section we're going to build a control rig as well. Reason being, I guess, it's quite important that we try to reduce the amount that maybe animators can grab hold of these joints, because if they delete something, it can be pretty fatal. Okay, so by creating a control rig, we can lock the joints off, and if an animation control does get deleted, it's a lot easier to rebuild. So I'm just going to quickly open this up here. You can see that rigs are pretty much just relationships. If I open this up, we can see we've got a series of relationships where everyone is connected in some shape or form, almost like a family tree. If I actually open up the hierarchy here, and look at this, we can see if I pull out that rig is simply just one big giant family tree. So that's why today we're looking at parenting constraints and hierarchies, because it is just to give you an understanding of how things can work together. What happens if you affect one object, how does it affect its children object, and how can we build relationships between different objects. Okay, so without further ado, I think we'll jump in. Okay, so in this part we're going to look at parenting and hierarchies. So I'm just going to create two objects, a polygon primitive sphere and also a cube. Here we go. And I'm just going to rename these parent for the sphere and child for the cube. Okay, so I'm also going to open up the outliner so we can see how these connections are made and just what happens to the hierarchies here. So at the minute both objects are free as a bird. You can see that they don't affect each other, and both objects are also children of this world. Okay, so the Maya universe, let's just call it, or the world space as it's known. And if I zero out these values, you'll notice that both objects will snap back to the center. Okay, so they are children of the world space. Now what we can do is, if I say, right, I want this sphere to be this cube's parent, I can select the cube, so the child object first, then I'm going to shift select the parent, or what I want to be the parent, and then hit P on the keyboard, or go edit parent here, okay, or just P, which is what I'm using. And what that's going to do is, it doesn't actually do anything in the viewport you may see, but if I come to the outliner, I can now see that the child object is living under the sphere, the parent. And if I zero out these values now, that cube is going to snap to the center of what it regards as its parent, okay, which is the sphere. So its world center is now this sphere here, okay, and wherever it's moving away, you know, this distance is how far it's moving away from its parent, the sphere. Okay, same with rotation, how much it's rotated away from its parent. But I can always zero these back out, and it's going to go back to its parent. Okay, this is going to be very useful later on when creating controls among many things. The sphere, though, however, is still a child of the world. So if I zero that out, that's going to still snap back to the world center. Okay, so very simply, we've created a parent-child relationship, and what we can also do is do the same thing in the outliner rather than hitting the P on the keyboard. So I'm just going to bring that out by hitting Shift P, and you can see that's now unparented it from the sphere. Again, edit unparent if you want to come to find out where it is. And this time I'm going to do it in the outliner. And the way to do that is just to use the middle mouse button and then drag and drop. So on the mouse, I'm just middle mouse holding, dragging, and then dropping over the parent, and it's going to do the same action, the parenting action. And again, to bring that out, to unparent it, I could do the Shift P on the keyboard, or I can just middle mouse drag and let go somewhere. Hopefully, come on, there you go. So you just middle mouse dragged and dropped it somewhere else. With parenting, I'm just going to duplicate this a few times. You don't have to parent one object at a time. You can select a whole group of objects. Again, everything selected will be the child objects, and then the last thing that we select, so if I shift select this, that's going to be the parent. Okay, so you can see now all of these cubes live under this sphere. If I just undo that quickly, if I select all of these, you can see the last object that we have in the selection goes green. And again, if I hit P now, all of these cubes that are highlighted white will live under this sphere, this cube here, sorry. Okay, so I'm just going to bring that out, parent these under here, and you can see that's going to take everything again. And what I want to do now is, we have a small hierarchy here of, actually let's look at this, the hypergraph. So we have a small hierarchy here of where all these child objects, these cubes, are living underneath the parent. If we want, we can make a bigger hierarchy by parenting maybe these cubes under each other. So I've just parented this cube under here. I'll select this cube, shift select this one, hit P for parent. Once you have an object selected and it has children objects, they're going to be highlighted green as well. So we can see these objects here. I'm going to take this cube, shift select this one, hit P. This can be parented to this one, P again, select that, shift select this, P, 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 and P, and then that is parented underneath the sphere. So now if we look at this hierarchy, we can see all of these objects, or this one is a child of this object, that's a child of this object, and then so on and so on. So we have a child, the parent, the grandmother, the great grandmother, the great great grandmother, the great great great, and so on and so on. If I now manipulate all of these objects, starting from the top, we can see the sphere is going to take everything, that's still in charge. The next cube down the line is going to take everything else, and this child is going to take everyone else, and so on and so on. So we have here pretty much just a parent-child hierarchy. Actually, let me just demonstrate that so it's a lot clearer what we've done. So if I create 3 cubes here, I'm just going to parent this under this one and this under this one. So what we end up with is a forward kinematics parent-child hierarchy, where the root of the hierarchy, this cube here, will carry everything. then the next one will carry the child. And if we rotate these all together, what we end up with is a forward kinematics type of movement, which we'll see a lot in joints, okay, or joint chains, I should say. But hopefully that gives you a basic understanding of how to do parenting, and also the hierarchies that we're creating and how they just how they work. Okay. Okay, so in this part we're going to cover constraints. So I'm just going to create two objects again, a sphere and a cube. And this time I will name the sphere to be leader, and the cube can be follower. Okay, and we're going to use a constraint, so I'll just open up the outliner. With general parenting, we saw that parenting changes the hierarchy, pops one object under another, so I'm just going to bring that back out. If I do a constraint now, so the sphere is going to drive the cube. The selection order happens in the opposite to parenting also, so instead of selecting the child object and then the parent, with constraints we need to select the object that's going to lead and then the object that's going to follow. So I'm going to select the sphere, shift select the cube, come under constraint, and I will do a point constraint. We can see here with constraints we can also just pop them onto individual channels or sets of channels, rather than having to, with parenting it will take over everything. So let's just do a point constraint. Let's just reset this and then hit apply. Okay, so the default constraint will snap the object to match the position of the leader. So if I just go to maybe X-ray, we see that cube will now follow this sphere. It doesn't match its orientation or its scaling, it just matches its position, since we've just done point constraint. Hierarchy wise, it's not sitting underneath the leader object, and what we get is this point constraint node that gets created, and this is where we can find the weighting of the object to turn it on and off. So this is the weighting here, and if I pop that to 0, the sphere now no longer has an effect over the cube. If I pop that weighting to 1, you can see that it now does have an effect over the cube. The other thing you can't do with constraints, or a limitation I guess you could call it, is with parenting we can still move the child object around, and it can step away from its parent in a sense. With constraints, if I just pull that out and I move this again, that object will snap back to where it came from, or where it needs to be. I'm just going to undo this, or I'm just going to delete that for now, and I'm just going to recreate this constraint again. Only this time I'm going to pop maintain offset on. If I add, what happens with the maintain offset is it uses these offset values to calculate how far away this object is from this one. So you can keep it at its current location and still make the constraint. Again, we can't move this around still because it will snap back. But what you could do is we can actually set keys on this. What happens is these channels have now gone green to indicate that there's two inputs coming in here, and we could animate this like so. If I just set another key here, if I move that around, this no longer has any weight over this, unless I come to this blend point node that gets created, or the pair blend node gets created. And with this here, we can then determine who's in charge. So is it the keyframes, or is it this sphere here? Okay, so that can be pretty useful, I guess. I tend not to use pair blending. I find it quite cumbersome, especially when you're trying to switch between what is leading, what is driving this object. So what I would usually use, if I just break this and maybe delete that, I use multiple objects to drive one object, and then use the weighting to determine who's in charge. So if I just create maybe a few more leader objects, we can select all three of these, then select the object we want to follow these objects, come on to constrain, and then come to point again. This time I'm going to just leave maintain offset on for now and hit add. Okay, so now if I select this and come to the constraint, we can see that all three objects, leader 1, 2 and 3, or leader, have 100% or a value of 1 weighting over this cube. So every one of these spheres will have the same amount of weighting to begin with. But what we can do is say we want leader number 2, oh no, that's the leader, this one here, to have full control. So if I pop the other two to 0, this is now fully in charge and everything else has no effect over the cube. If I come back and say, right, I want to turn that off, and I want maybe number 2 to have full control, so this is number 2 here, so that now takes over. So this can be pretty useful for things like FK, IK switching and space switching, and I find this a much more reliable method to switch between who's in charge of an object. Okay, so that's constraints in a nutshell. There are a lot more constraints in here that we could go through, but I think we'll see to them as and when we need to while we're rigging the actual character. Okay. Okay, so next we're going to look at joints, which are without a doubt the main tool you're going to use for character rigging. Okay, so this is going to build the skeleton for your character and it lives underneath skeleton. So I'm just going to go to a side view or right view. I'm just going to go skeleton joint tool, and when you activate the tool you get a little crosshair, and then you can left mouse click to start creating the joints. So the joints are the little circles with the crosses running down them. These are the pivot points from which your character will articulate. So the placement of this has to be spot on. Okay, very important. If I actually left mouse click, what you can see is the parent joint beforehand will always aim at the child joint. Okay, this is a child joint on its own, so it doesn't aim at anything. But if you just watch this little green one here, when I make another click, you'll see it then aim at its child joint. To come out of the tool, we can hit enter on the keyboard, which will then leave this for us. If I delete that, another way to come out of the tool, which I tend not to do, is use the right mouse button on the keyboard, on the mouse. And what that actually does is it creates one final joint where your crosshair is. Okay, and then brings you out of the tool. So I tend to just hit enter on the keyboard. Oops, I'm zooming in somehow. And then, yeah, when I'm done, just hit enter. Okay, so here are 1, 2, 3, 4, 5, 6 joints that we've created. And if I select any one of these, my rotate tool is set to local. We can see that, oops, where's it gone? The axis is always going down the joint, pointing at the child. Same here, same here. The rotations are all 0, and the reason for that is not that. Is because of because joints have orientation. Okay, so the only transform nodes in Maya that have orientation, and this allows the joints to aim towards its child joint, or the parent joint to aim towards its child joint. If I rotate this or edit this, we can see that we can rotate the joints. The values here still stay at 0, but the parent joint is still aiming at the child. If we go to the translate tool, I'm currently set to world, it looks like. But if I switch that to object, we can also see that that joint is aiming towards the child joint along the x-axis, and this gives us the length of the joint. So this length here, or this joint here, should be 11.339 centimeters. I think I've set mine to, should be centimeters. So if I actually go create measure tools, distance tool, and snap from that point to this point, we can see we've got 11.339. Okay, so the child joint will always give us the length of this joint before it. If I update this, again I'm increasing the length of this joint, snap that here, we've got 18.74, again that's 18.744. okay, so what I don't want to do when creating joints is do this. Well, actually I can, and I'll show you how to clean it up in a bit. but I can rotate the joints to position them like so. But what I want to make sure I do is get rid of these values here so they're clean. So if an animator wants to go back to the default pose, he can just punch a 0 in. You can see it's going to snap at the minute. So the way you can do that is you can just come under Modify, Freeze Transformations, make sure Rotate's turned on, and just hit that there. And that's going to then send those values into the joint orient here. Okay, so if I just go like this, again, go Modify, Freeze Transformations, you can see it pops it into the joint orient. And again, very useful because now the animator can go, right, I want to do that, zero it out, and it's back to its default pose. Other than that, you'll notice that this joint chain is a parent-child hierarchy, as I've probably said already. And if we come to the outliner, just delete those, we can see that hierarchy here. Okay, so this is the parent joint, its child joint, then its child joint, and so on and so on. If I select all of these, let's make that smaller. Actually, I'm going to draw a different chain so it's cleaner. I'm just holding down the shift key here just to create a straight joint chain. And if I select all of these, I'm adding to the selection, so I've got all of these selected one by one, and rotate them together. We then have a forward kinematics chain. Okay, I can select one of these, that's going to take all its children, but selecting all of these you can get some very nice shapes happening very quickly with forward kinematics, or some crazy witch finger going on. So that's joints. Before I forget though, I guess in terms of me being uber draconian, what I like to make sure, or when I'm creating joints, I tend to want to make, let's just say this is my funny character with an odd spine like this. I tend to follow a few guidelines, I guess. So the first being the first root in the chain can have values in X, Y, and Z. Okay, because that's how it got there, pretty much, that root. But then every other joint can only have a translate value of in the X channel. Okay, if I do this, you can now see that what happens is I've got values here, which I don't want, and then what also happens is this joint is no longer aiming at this joint here. Okay, and that can cause issues if you're trying to maybe twist this joint around. Okay, so I always have it so there's only a value in the translate X, which means to position my joints I'm using the rotation, but I'm always going to freeze transform the rotation, so that's clean, so it feeds it into the joint orient, and I'm going to use the translate X. Okay, so just rotation and translate X, or pretty much just joint orient and rotate X, or translate X, sorry. Okay, and that's going to give me just clean joint placement. What have I done there? Okay, so I'm just selecting these, the translate X, and middle mouse dragging in the viewport to interactively edit this value. And again, I've got some rotation values here, so I'll just select all of these for now. Modify, freeze, transform to get rid of the rotations. Now everything's just got a translate X value, which again indicates the length of the joint. Okay, so that's a quick introduction to joints. We'll be using these all over the place later on, and we'll also get into more depth about how they work as we go. Okay. Okay, so in this part we're going to cover rotation order and gimbal lock. So I'm just going to go into the front view and create a free joint chain like so, and I'm going to pretend this is an arm. Actually, maybe I'll do it like this, so it looks like the shoulder, elbow and wrist. And I'm just going to quickly rename these. So shoulder underscore J and T, so that's going to be my suffix for all joints. So I'll just copy that maybe, and this is going to be the elbow. And you can see, oops, what have I done? When I'm selecting joints, you select this segment here in between the joints. That's going to select the parent joint here. Okay, so if I want this joint here, I'm not going to just click there, I'm just selecting here. Again, that's going to select this joint. This one I have to select here because it hasn't got a child joint. Rotation order. So if I just come to my rotate tool, and again I'm set to local mode. Usually when you rotate in local mode, things always seem okay. Okay, so I always look like I've got an x-axis, a y, and that was a z, and a y-axis. Okay, if I'm just going to zero this back out, I switch that to gimbal, we will then get an accurate representation of what's happening with the axes. So if I take this z-axis, that's taking everything, the y and the x with it. But if I take the y-axis, we can then see that the z is staying in place. If I keep going with this y-axis, what we end up now is two axes, the x, let me make this bigger, the x and the z sitting on top of each other. So at this stage we've hit gimbal lock. Okay, if I try and take the z-axis now and the x-axis, I'm getting a very similar type of movement happening. Okay, so this is gimbal lock, where two axes sit on top of each other. Let's just zero this back out, and we can find the rotation order of how this is happening. If I select the joint and go to the attribute editor, we can find that information here. So rotate order there. And we can see at the minute, by default, everything is always set to x, y, and z. And what that means is that z will carry y and x, which it's doing. Y is going to carry x, and then x isn't going to carry anything. Okay, so z is in charge of everything, y then comes next, and then x comes last. We can switch this by just clicking, and let's just try z, y, x. I tend to read it from right to left, hence why I was trying to read it x, y, z. So z, y, x, and what that means is x here is going to take everything. Y again is in the middle, so that's going to take z, and then z or z, as I should say maybe, doesn't take anything. Okay, and the reason why I'm showing you this is sometimes you may need to come in here and change the rotate order to suit what your character needs to do, because there's no way really to get around gimbal lock unless you start adding extra levels of control on top. So you have another layer of control to get you out of, getting in the gimbal lock like this. So maybe you have an extra control that says, aha, I can pull this back out and take over. So you may have to come here and say, right, I know for my character it needs to maybe lower its arm and then pull its arm forwards 99% of the time, and it's not going to twist much. Therefore you'll maybe set your gimbal lock to support these two actions, and then say, yes, you may get into gimbal lock with the twisting, but chances are we don't need to use it for this particular part of the rig, or we're going to use it very minimally, so we can get away with that. Okay, so the last thing we're going to look at is creating animation controls. So I'm just going to go into the front view and create 3 joints again. So this can be the arm again. And I'm just going to very quickly come in here and rename these joints again. So shoulder underscore JNT, elbow underscore JNT, and wrist underscore JNT. Okay, so to create animation controls, it's pretty much going to take everything that we've looked at so far and then wrap it up. So I tend to create nerves primitive circles, or come under CB curve tool and maybe design my own control. We can turn on grid snapping if we wanted to and make something fancy. Don't know what I'm making here. Oops. Before I do that, come under here and turn off, or turn that to 1 linear, and same again. So again, I'm not really doing anything special here, but I can hit enter, and that could be my animation control. But for now, I'm just going to use a NURBS primitive circle. Okay, so there's the control there. I'm going to rename this to be shoulder underscore CTRL for control, and open up the outliner. Just bring this out. So for this control here, I need to get it to match the same position and orientation as these joints. So I could take this, parent it under this, and then hit 0. So again, just creating a parent-child relationship, zeroing out the values and then unparenting it. And what that's going to do is, can we see that this is synced up perfectly? So we could create a constraint now where this drives this joint. Actually, let me just do that. Constrain parent. Well, let's just do constrain orient for now. And again, you can see there's no pop during that constraint. If I just undo and add a slight variation, rotation to this control, and then do the same again, just make sure that's turned off, you can see the joint pops. Okay, so that they're not aligned correctly. So again, very important to make sure that they are aligned perfectly, which I'm just doing now. So I'll just do that again, constrain orient, and what we get now is we can manipulate the joint because we've made that constraint. But if I want to zero out this value, that's going to happen. Okay, so that's not good. So you could say, right, we can take that and just go modify freeze transformations, and what that will do is that will take this back to being, y is up, x is x, and z is z, when it was like this. So that's not good either. Okay, so we don't want to go modify freeze transformation to our controls, because that's going to change our orientation as well. So I just bring this back to world 0. What I'm going to do is I'm going to hit Control G. I'm going to do it twice, and I'm going to create a small hierarchy for the control. I'm just going to rename this shoulder auto. You can, I guess, call it what you like. So this level of control is just going to allow me to add automated attributes such as set-driven keys. Maybe I'll demonstrate that quickly as well in a second so it's clear. And for this one, I'm just going to call it shoulder underscore offset. And this layer of the control is used to position the control. And this is going to take all the values of how that control got into place, pretty much. So I'm going to take the offset value, shifts, or this is going to be the first way in which you can get it into the right place. I'm going to shift select this joint that's going to control, hit P for parent, 0 out the translate and rotate values, so that snaps into place, and then shift P to bring the offset value, or the offset node, back out. Okay, now where this lives, or this control lives directly underneath the offset value, it's going to have values of 0, because at the minute it's at its home. Okay, it's with its parent. Same with this one here. This one, which is a child of the world, does let you know how this control got to where it is. Okay, but because these are group nodes, the animator is never going to grab these unless they're a bit naughty. Okay, they should just be grabbing the controls that they see in the viewport, which is this control here. And now if I create a constraint between the control and the joint, constrain orient, this will now take the joint, I can zero it out, and I'm back to that pose. Okay, so the starting default pose. Again, this one here is going to allow for automated attributes. So if I was to, let's just create a, what we're going to do, I'll do a locator, create a locator, got this turned on still. And I just call that bend, maybe, and add an attribute. I'm going way deeper than I intended, but oops. Let's just call that curl. Give it a minimum of 0 and a maximum of 10. Default of 0. Okay, so what we can then do is use that to drive this auto control here. So if I just go set driven key, load this as the driver, curl, the automated node is going to be the driven object, and again we'll come into this later on, but for now I'll just do it very quickly. That's going to be on the Z axis, so hook that up. Key that. Get rid of all of this, we don't need that for now. Donk. Okay, so what we can do now is we now have this control here, and we can imagine this being a hand control maybe for the fingers, and we can use that to drive this auto attribute here. So you can see there it's driving that, and again we'll get into this a lot more later on when we come to fingers and thumbs. But on top of that, because this lives underneath this control in our hierarchy, we can still animate on top of that. Okay, so it's just added an extra layer of control to our rig. Okay, so I'm just going to zero all of this out and delete it for now. But hopefully that just indicates what this level of the control does. Get rid of this, that's now broken. So that's how we place our controls, and that's what these layers do. If I do want to edit the scale of this control or the position so it's easily selectable, I'm going to do that in component mode, because if I did it in this mode here, it's going to change the pivot point for where that rotation happens. Okay, so I'm going to hit F8 on the keyboard to go into component mode, and I can grab these and do whatever you like. You know, this isn't going to affect the pivot for the object. Maybe not that, but hopefully that gives you an idea of how you would shape the control. Maybe I'll leave it there. Okay, so I just hit F8 to come back out, and again the pivot's exactly where it is. We've just changed the shape. So I'm going to create another control for the elbow. So I'm going to go create Nev's primitive circle. Just call this elbow underscore CTRL, and group that twice. Just going to copy this. Actually, all of these should have CTRL in there. Oops. And do the same again. So that's going to be the auto, and this is going to be the offset. And this time, to position this control, I'm not going to do the parent, zero out the values, unparent. We can do it like this as well, which is to select the joint is going to control select the offset node. And again, you have to do that in the outliner because you can't select the group node here. And go constrain, parent, the options, turn off maintain offset, then hit add. That's going to snap into place, and then we can just delete the constraint. So it does exactly the same thing, it's just how you want to go about getting them into place, I guess. And again, I can select this control now. I can go into component mode and edit its shape. And then, oops, I can constrain this joint now to this control. So select the control. Again, this is the NURBS curve. Shift select the joint, constrain orient. And now this will take the joint. Nothing pops, so we know it's fine. We can zero out the values for the rotation, and everything's pretty hunky-dory. But if I take this, you can see we get a funny movement happening, and the reason for that being that this joint is trying to take charge of this, where the or this control, sorry, is trying to take charge of this. But the joint structure is a forward kinematic structure. Okay, so we see that the shoulder's in charge. That takes the elbow, that takes the wrist, and we need to mimic that behavior within our control structure. So to do that, I'm very simply going to take the elbow control's offset node, and then middle mouse drag that underneath the control node, okay, for the shoulder. And now we've created that parent-child relationship here. So if I take this now, that carries everything, and then we can take this and rotate that. Okay. Another thing you can actually do with I guess moving around the hierarchy is if you have anything selected in the viewport, you can hit up on the keypad on your keyboard to pick walk. Oops. Okay, so that's just pressing up and down to move up and down within the hierarchy, which is pretty useful. So hopefully that gives you a good introduction to some of the tools we'll be using, and then next time we'll start actually rigging the spine of our character. Okay, hope that helps. Thanks.